Okay, for adrenal cortex, it will secrete a glucocorticoid. An example that we'll mostly focus on is cortisol. Cortisol is the major glucocorticoid hormone, and it is stimulated by ACTH. So ACTH comes from anterior pituitary. When ACTH binds to adrenal cortex, then adrenal cortex will secrete cortisol. What does it do? It breaks down proteins into amino acid so that liver can use amino acid to make glucose. We call this gluconeogenesis. It also breaks down fatty acid. It also breaks down body fat into fatty acids so that our liver can also use fatty acid to make glucose. This is another example of gluconeogenesis. And then the overall effect is to increase the blood glucose level to deal with stress. Why? Because when we have more glucose, then we can make more ATP through cellular respiration. When we have more ATP, we have more energy. We have more energy, we can use the energy to deal with stress. And we can also use this to deal with inflammatory responses. The cortisol can also suppress the immune system. Now, and the second type of hormone that will be secreted by adrenal cortex is called mineralocorticoid. Mineralocorticoid, secretion of mineralocorticoid is not controlled by anterior pituitary. An example of mineralocorticoid that we talk about is the aldosterone. Aldosterone works on kidneys. It increases the reabsorption of sodium and water. Most importantly, water. In order to restore the blood volume and blood pressure. And what causes the secretion of aldosterone? Remember in our urinary system lecture, we talk about RAA pathway. So it is the secretion of renin, which is an enzyme from the kidneys. And then this renin enzyme will convert angiotensinogen into angiotensin 1. And then angiotensin 1 will be converted into angiotensin 2 by the angiotensin converting enzyme secreted by the lung. And then angiotensin 2 will induce the secretion of aldosterone in adrenal cortex. So renin is an enzyme secreted by kidneys. When it is released, renin is released when the blood sodium level, blood pressure are low. So as I told you previously, renin will activate angiotensinogen into angiotensin 1. And then angiotensin 1 will be converted into angiotensin 2 by enzyme. We call it ACE, angiotensin converting enzyme. It is produced by the lung. And then angiotensin 2 will stimulate adrenal cortex to release aldosterone. So angiotensin 2 will cause vasoconstriction, and then vasoconstriction will decrease the glomerular filtration rate, if you still remember what glomerular filtration rate is. And then aldosterone causes the kidney to reabsorb more water, sodium, so that means more sodium will go to the blood, making the blood more concentrated. Then water follows. Water will go into the blood as well. In this case, we will increase the blood volume and increases the blood pressure. So here, it is just a review of the RAA pathway that we talked about last time in the urinary system. So we talk about this part, the renin, angiotensin 1 and 2, and aldosterone. This part, it is when we have lower blood pressure, low blood pressure, then you will have to raise the blood pressure. But when do we have lower blood pressure? For example, if we lose too much water, if we lose too much blood, for example, hemorrhage or diarrhea or dehydration, all these can cause the lower abnormal or lower blood pressure or lower blood pressure. Then we will use the RA pathway to help to bring the blood pressure up. On the other hand, if you have high blood pressure, we'll go through this. When you have too high blood pressure, then our atria will be stretched. When the atria is stretched, then the atria will secrete something called atrial natriuretic hormone. We'll talk about this hormone very soon. This hormone, atrial natriuretic hormone ANH, will stimulate your kidney to excrete more sodium and water, so that we will decrease the fluid retention in the body, then to lower the blood volume, and so that it will lower the blood pressure, to restore the homeostatic blood pressure. So now let's talk about this. This one, theoretically, it should not consider as mineralocorticoids because it is not secreted by the adrenal cortex. Atrial natriuretic hormone, Atrial suggested that this hormone is secreted by atrium. It's produced by the atria of the heart when the heart is stretched. When will the heart stretch? When there's an increase in blood volume. When we have too much blood in our body, then our atria will stretch. When our atria stretch, then it will secrete this hormone. This hormone inhibits the release of aldosterone. Therefore, result in natriuresis, excretion of sodium in the urine. When we have sodium, when the concentration of the urine increases because we have more sodium ion, then water follows. That means water will go from the blood into the urine. So that will decrease the blood volume, and in turn it will decreases the blood pressure. So ANH, anti-natriuretic hormone, is a natural blood pressure medication. It helps to lower our blood pressure, but it is produced by our own body. So it is a very good one. So it summarizes what we just studied now. For the short-term response, if we have stress, what happens is that we will have this is our nervous system, the autonomic nervous system. This is the preganglionic neuron, sympathetic neuron. It has direct innervation to the medulla cortex. Adrenal medulla. This is the adrenal medulla. The preganglionic sympathetic neuron directly innervate the adrenal medulla. So the adrenal medulla can secrete adrenaline, epinephrine, and norepinephrine. This is short-term of fight or flight response. For long-term dealing with stress, we have also starting from hypothalamus, secreting hypothalamic releasing hormone. In here, we call this CRH, corticotropic releasing hormone. CRH will stimulate NPIT, anterior pituitary, to secrete ACTH. ACTH, adrenocorticotropic hormone. This hormone will be released and bind to the adrenal cortex. Adrenal cortex will then secrete glucocorticoid and mineralocorticoid. Glucocorticoid, for example, cortisol. Mineralocorticoid, for example, aldosterone.